Hi, on this video I'm going to show you the glide module and how it works. The glide module is a modifier. It modifies an incoming signal. So whatever enters in its main input is going to come out modified. Instant jumps are going to be smoothened. So let's try to plug the gate signal, which is an impulsive signal which goes from 0 to 5 volts instantly. Here we have two oscilloscopes. This one shows us the original gate signal and this one shows the modified signal. Let's plug the gate signal here and the copy here incoming into the glide and then outputting from here. Now I'm going to increase the glide time and let's see how the signal changes. As you can see, whenever I press a key, the gate signal originally instantly goes from 0 to 5 volts, while on the second case it takes some time to get to 5 volts. That's what the glide module does. So how do we use the glide module to get the glide effect? To get the glide effect, we slow down the pitch signal. The pitch signal is that signal whose voltage depends on which key has been pressed. So if we press C3, for example, we're gonna get 1 volt. And if we press C4, we have 2 volts. So each key has its own voltage. Normally, the pitch changes instantly. In this example, I plug the pitch signal this time. On the left, we have the original, and on the right, we have the modified pitch. So when I play one key and then I play the other one, you see that originally it takes no time to get from one point to another. The VCO receives this signal and generates the frequency corresponding to this signal. But if we slow it down, the pitch signal, then the oscillator is going to produce a frequency which changes following the pitch, which has been slowed down. So that's how you get a smooth transition between notes. On this basic patch, I'm going to apply the glide effect. So all I need to do is to make this pitch go through a glide module first and then plug it to the pitch CV input. So let's plug the pitch CV here and then the output will go as normal. Right now there is no glide effect because we have set no time. But if I increase the time, now we have a smoothened pitch CV, therefore a smoothened note transition. Let's visualize how the glide modifies the pitch CV. So when I play one note and then I play another note, you can see that originally the pitch CV is instant and the oscillator would change its frequency instantly. Instant change of note. But if we slow it down by the mean of the glide, now we have a smooth transition between two frequencies. That's how the glide works. That's how you get the glide effect, a smooth transition between two notes. Now let's talk about the two glide modes, linear and constant. On linear mode, the time it takes to the signal to go from one point to another depends on the distance. The more distance, the longer the time it takes. If we play two very close notes, it's gonna take no time. So the glide will barely be audible, while if we play two more distant notes, like an octave, then the glide effect will be more audible. So long story short, you use linear mode when you want to hear the glide only for big jumps, and you don't want to hear it when you play close notes. Now let's talk about the constant mode. On constant mode, the glide time is always the same, aka constant, no matter the distance. So if you play one octave, or if you play two very close notes, it doesn't matter. Even if the distance is very different, the glide time is gonna be the same. As you can see, even if the two notes are very close between each other, it's gonna take a long time to get from one point to another. So when do you wanna use this constant mode? Well, when you wanna hear the glide effect no matter what. Always, all the time. So long story short, you use linear mode when you wanna hear the glide effect for big jumps, and you are not very interested into listening to it when you play very close notes. And you can be very generous with the glide time. On constant, you need to be more careful. You use it when you wanna hear the glide always, no matter what, but you need to be more careful about the time, because it's very simple to break the sound and make an unplayable patch. As you can see, I cannot play a melody, so you need to be very gentle. So use your ear. Normally on linear mode you give more time, on constant you give less time. That's the principle. Use your ear, that's how it works. Now, the external engage, don't worry, it's just a switch on off. You plug, for example, the gate signal or the trigger signal to turn the glide on and off. It's like a switch. Know that this is the main use of the glide, to slow down the pitch CV, that's its main use. But the glide can be used for more advanced and niche uses to slow something down. So for example, you want to slow down a random stepped CV, control voltage. You don't want to make it by steps, you want to make it smooth, then you can slow it down. I'll show you. On this patch, for example, we have a random stepped control voltage, which has been slowed down by this glide. Normally would be like this, instant jumps. The glide allows us to make it smooth and get more continuous automation. This automation curve is controlling the cutoff, so now the cutoff doesn't jump instantly, like this. The glide allows us to get a smooth transition. So this is a more advanced use of the glide module. So the principle is the glide allows us to slow down anything we want. The main use is to slow down the pitch CV, so this way we get the glide effect, the smooth transition between two notes. But be aware that the glide can be used to slow down anything we want to slow down. So that's it. I hope this video was helpful and I wish you a good study.